Hi everyone, my name's Morgan and I'm an educator at the Museum of Science. Here in Boston, days like this can be perfect for sitting in the sun and soaking up the rays. But sometimes the heat can get a little bit overwhelming and our houses can become too warm to stay inside of. In this video, we're going to learn about why things like the sun can keep us warm without even touching us, and how we can use this knowledge in order to make things warmer or cooler in order to stay comfortable. Let's head inside to learn more. When things heat up or cool down, we call that thermal energy transfer. Thermal energy, or heat, is always moving, and it always moves from areas that are warmer to areas that are cooler. When thermal energy moves through electromagnetic waves, we call that radiation. Now, electromagnetic waves are ways that energy is transferred over really long distances. Sometimes we can see those waves, like with visible light, but sometimes those waves are invisible, like with X-rays or radio waves or microwaves. I think that's what makes radiation so fascinating to learn about. It's invisible and it's contactless. Think about it. When we feel the sun's heat, we're not actually reaching out and touching the sun, and we can't actually see the sun's rays touching our skin. Yet, we feel warm because energy is being transferred to our bodies. What's even more cool about radiation is that it's not just the sun that radiates, but anything with heat can radiate, including our own bodies. Let's take a look with a special tool. Right now, I'm standing in front of an IR camera, which allows us to see wavelengths of light on the infrared spectrum, which our eyes alone can't process. Parts of my body are glowing a yellowish-white color, which means that they're radiating a lot of heat away from me, while some parts of my body are glowing a bluish color, which means that I'm radiating less heat. Can you tell which parts of my body are transferring the most heat to the air around me? Like all types of heat transfer, we can't stop radiation from happening, but we can slow its movement. For example, if I wanted to keep the thermal energy that I have in my body from radiating outwards, I could put on a coat. A coat, depending on the material, is a type of insulator, which means it slows the transfer of thermal energy. What do you notice about the change in color on the IR camera when I put my coat on? How might this show that the heat from my body is staying close to my body instead of radiating away from it? Engineers can think about what type of material we use for clothing in order to minimize or maximize heat transfer. And we can think even bigger picture too. The streets that we walk on and the houses that we live in are also affected by radiation. The sun can heat our sidewalks and it can heat the roofs of houses, so that when we touch these things, they're sometimes very, very hot. Different materials absorb or reflect radiation differently, so engineers can use principles of thermal energy transfer in order to choose materials that can help to control the effects of radiation and to keep people comfortable. Let's do a little experiment. I have this mini house here, and I also have 4 different roofing materials that we can choose to put on top of this house. We're going to see if any of these materials heat differently. One of these roofing materials is made of a black tar, another one is a white corrugated plastic, another one is aluminum with bubble wrap, and finally we have a wet moss. If the goal of an engineer is to keep a house cool, the best material might be one that heats the slowest. If the goal is to keep a house warm, maybe the ideal material is one that heats quickly. Take a second and talk to a partner next to you. Which of these materials do you think might heat really quickly, and which ones might heat slowly, and why? Let's see how the temperature of these different roofing materials change over the next 10 minutes under these heat lamps. We'll be looking at this through an IR camera, so remember, materials that are glowing a reddish or white color are materials that are radiating the most heat. Well, if we see a blue or a green color, that means that the materials aren't radiating as much heat. What do you notice about the colors of the roofing materials on the IR camera? It's been about 10 minutes, so let's measure the temperature of the different roofing materials. The roof with the moss on it is about 87 degrees. The roof with the aluminum and the bubble wrap is about 88 degrees. The corrugated plastic is about 105 degrees. And the black tar is about 130 degrees. Do these results support your predictions? Or if there's something unexpected, can you think of a reason why that might be? You can all try this for yourself too. Find some materials around you and try to do a similar experiment. Remember, make predictions, measure your results, and modify your design to create the most energy-efficient roof that you can. That was awesome! We learned about how thermal energy is transferred through radiation, and we used an IR camera to explore this, since radiation is invisible to our eyes. Understanding radiation helps us do things like wear clothing that insulates our body heat in the winter, and also design buildings that keep us cool in the summer. Throughout the day, keep on thinking about how radiation affects the things around you. The more we understand it, the more we can design creative and innovative solutions to keep us safe and comfortable. Stay cool, engineers.